The goal for this kaggle challenge is to find a way to predict house prices in the city of Ames in Iowa. This is a regression problem as we are trying to infer with the best accuracy the price of a house given a data frame of 79 explanatory variables. The real value of this analysis is due to the fact that it's always very hard to negotiate and to agree on a final price for a house during a purchase. For a real estate agency, knowing a good estimate of a property means maximizing its income, leveraging the level of engagement of the client, and most of all, decide which houses can be more profitable to deal with. Furthermore, we will have to find out which factor influenced the most the final prices of our houses. Let's take a real example. If a real estate agent has to choose which house to invest in, having two different clients offering houses at the price of $270,000 and $200,000. The decision might be not so easy, even taking into account his ability of assessing the value of those houses. Maybe he could go for the cheapest one to minimize the risk, but if we have an algorithm can accurately determine the price of such properties, the decision can be made right away with a good degree of certainty. Since we have too many variables in this dataset, it's hard to understand at first sight which ones are more relevant and which ones are completely uncorrelated with the house price, our final objective. The technical difficulty here is basically finding the right model that summarizes and explains the price, given the set of information at our disposal. We will focus on this as well on the visualization of important features in the second delivery. Another important challenge regards pre-processing. The data set is not ready for machine learning analysis, so we have to take care of every piece of data which hinders our purpose. For example, we have to deal with missing values and outliers.
For the next part, we are going to start with the data description. The kaggle challenge gives us, as Alicia told us before, the goal is the prediction of the final sale price. That's why we have a train set and a test set as files to work with. Both of them has 44 columns with string variables. Most of them are ordinal factors such as the quality from low to excellent in different grades. Another 37 columns has numeric variables from the year the house was built to the square feet of the garage. Once we have the data set in R, we start the preprocessing. First, the missing values treatment, then factorizing the remaining character variables, and then changing some numerical variables into factors. As we can see, the number of missing values in sale price match the size of the test set, so we have to fix the missing values in 34 columns. As one example, we are going to analyze the variable with most missing values. The pool quality is described as excellent, good, typical, fair, and no pool. So we are going to transform into a vector from 0 to 5. Another variable related to pool with NAs is the pool area. As we expect, the houses without pool has 0 pool area, and the ones with pool has more than 0. But we found that there are 3 houses with pool area greater than 0 and 0 pool quality. So we are going to use the overall quality transforming to be an input for the pool quality. Also, within the miscellaneous feature, there are a lot of missing values. As the values are not ordinal, we transform it into a factor. This means the ones with missing values will have a known in this feature, and the rest could have one or more factors describing the house. Another good technique used is in the variable referring to the linear feet of a street connected to the property that has 486 missing values. So we found a reasonable input is the median of the neighborhood where it is located. Now we move to the garage. Different factors referring to this place. For example, for the garage type, we transform it into a factor and the missing values will be known value. It's weird that we found the rest type has 157 missing values and the rest has 159 missing values. Those two are these two examples. To solve the first one, we use the most common values for each variable, as we appreciate seems to exist a garage. On the other hand, the second one seems to has no garage, so finally there are 158 houses with no garage at the end.
Okay, now this is due and it's the statistical analysis of some variables. First, the most concerned factor is response variable, sale price. And from the red picture, you can see our sale price vary from 35K to 750K, and our average price is around 180K. The sale prices are red skewed. Few people can afford very expensive houses which prices are over 500K. And what's more, 50% of the population is concentrated in the interval between 130K and 214K. In order to figure out the most important factor of houses, we did a correlation analysis of variables with sale price. 10 numeric variables with a correlation of at least 5.05 point, and all those correlations are positive. Our highest value is overall quality 0.79, and the second important is above ground living area with the value of 0.71. So next we did the independent analysis of the two most important variables. For the overall quality, there is a clear correlation with sale price, and the overall quality rates the overall material and finish of the house on a scale of 1 very poor to 10 very excellent. Also, there is very few outliers, probably only one in level 4. For above grade living area, it seems that big houses are generally more expensive, although the correlation is not so evident if we look at the very big houses. And there is some outliers also. For example, the 524 and 1299. But it's dangerous to animate outliers because they might be there for other reasons. Maybe the house is very old, but we can see from this graph. For the future analysis, we plan to divide it into 3 parts. The first part is data visualization, and the second one is feature engineering. The last one is modeling, and including the lasso regression and XGBoost.
So we can see here in the R notebook the correspondence with what we talked about in the slides. We start by including the necessary libraries, and then we proceed by loading the dataset. In this part, we see the descriptive statistics that we mentioned. In particular, we perform point estimation on mean and standard deviation to analyze our population, and we can also see the quartiles that the built-in summary function returns. Scrolling down, we have the analysis on the correlation to understand which variables explain better the price that we want to predict. And finally, we reach the part where we deal with the missing values. This is the more significant segment, as is in terms of code it consists of several hundreds of lines. although this is only due to the fact that there is the need to run through each one of the 80 variables separately, while the operation on the data are more or less always the same. Substituting NA values with none, changing ordinal variables with numbers in order to compute statistics on them, or also factorizing string variables.